land down under, home to some of the most stunning places on Earth, and the home of Dr. Michael Denton. As both a physician and a biochemist, Dr. Denton has done extensive research on the fine-tuning of nature for the human body. In this episode, we'll examine the delicate balance of elements that compose our planet and our bodies, and ask, if things were slightly different on Earth, would human life be possible?
Many years ago, I was working at the Prince of Wales Hospital in Sydney, in Australia, as a clinical chemist, monitoring ICU patients. And the body's functions are set for a particular level of acidity in the blood. All sorts of things in the body simply don't function properly once the level of acids has changed. For instance, if you have a severe lactic acidosis and you don't cure it, it's going to be rapidly fatal. The critical necessity is to keep the level of acid in the blood within a very tight range. To do that, the body contains a thing called buffers. If the acid goes up, the buffers absorb the acid goes down, they give some acid off. And without a buffer maintaining the acidity in the blood in the normal range, we'd be in great trouble. So how do you get this buffer? It's called the bicarbonate buffer. Well, it's amazing. In respiration, breathing air in and out generates waste products. One of them is carbon dioxide, the other is water. They come together to make carbonic acid, which dissociates into the basic form bicarbonate buffer. And it turns out that this bicarbonate buffer is just what you need to buffer the acidity in the blood. That struck me at the time very powerfully. If the properties of bicarbonate were slightly different, we wouldn't be here.
Denton was stunned by his discovery. The waste products of breathing, carbon dioxide, and water spontaneously combine to produce a new compound, whose inherent properties just happen to be essential to keep the acidity of our blood within life-sustaining levels.
It staggers me. You've got only 6 atoms in those 2 compounds that come together spontaneously and you get a buffer. I found it absolutely stunning because these properties were part of the order of nature from the very beginning. And I remember many nights in intensive care thinking of this and feeling quite extraordinary feeling of standing in the presence of a great intelligence that had foreseen the needs for an air-breathing organism like myself from the very beginning of time.
Denton's realization started him on a lifelong quest to discover other ways the chemistry of the universe might be finely tuned and fit for the human body.
Eventually, I sort of made it one of the major aims of my life to investigate the phenomena of fitness. And I found there's a vast number of properties of matter which are extraordinarily fit for our being. And if you change any of them, we wouldn't be here.
Nowhere is the fine-tuning of matter for our bodies more apparent than in oxygen.
Oxygen is a gas, and we need amazingly huge amounts of it. We need a cup of pure oxygen every minute to supply our metabolism with enough energy to keep us going.
But there's a problem with relying on oxygen for energy.
The oxygen in the atmosphere clearly can be very, very dangerous. We can see the fantastic reactivity of oxygen. One cigarette and you can burn a whole forest in a very short time. And we know, living in Australia, it can cause catastrophic changes. We need an atmosphere that's greatly enriched in this particularly reactive substance. And the question arises is, how do living things like us live comfortably with this gas? And why don't we spontaneously combust?
It turns out that oxygen is fine-tuned to be relatively non-reactive in the temperature range typical on our planet and inside our bodies.
Forest fires require temperatures over 105 Fahrenheit and more. Heat activates it. But at the temperature range in which we exist, it's relatively unreactive. This is because, in fact, oxygen at body temperature has a thing called spin restriction, which is an energy barrier, which means that oxygen is not really dangerous unless you heat it up. Without that energy barrier, we wouldn't be here. We would be spontaneously combusting. And all the forests, there'd be no forests at all. With the level of oxygen in the atmosphere we have now, if it wasn't for that energy barrier, there'd be no vegetation on Earth and there'd be no advanced beings like us, for sure. That energy barrier is absolutely critical to our living.
But the energy barrier related to oxygen presents another challenge. As previously noted, oxygen is essential for providing energy to the human body. But at our body temperature, oxygen is inactive. That keeps us from combusting, but it doesn't keep us alive. Somehow, oxygen must be activated for metabolism if we're going to get the energy we need for life. Fortunately, two other elements in our bodies provide just the right solution.
And so the oxygen in the body is essentially inert, unless it's activated specially by transitional metals, basically iron and copper, which can activate oxygen without heat. That's another element of fitness. And the beauty and elegance of this is incredible, and the parsimony is amazing. Without those transitional metals activating oxygen in the body at low temperature, we wouldn't be here. It fits with great elegance in the overall developing picture that nature is ordered for our sort of being. So we're accumulating different evidences of fitness.
Another substance fit for the needs of the human body is water. Among other things, water enables our body's circulatory system.
Just a few basic points about what you need for a circulation. First of all, you need a fluid, a liquid state, to have a circulation. And then you need a very good solvent to carry the vast numbers of metabolites that are necessary to maintain our life. And you need a low viscosity because you want to pump it through tiny capillaries. And you need something which is relatively light, which doesn't overburden the heart, which can actually be forced through the circulatory system. And water has all those properties. Particularly, it's an excellent solvent, has a very low viscosity, and so forth. And so the wonder fluid water has unique features for the circulatory system.
Water also has unique thermal properties that keep the human body cool enough to function.
Water has just the thermal properties you need. First of all, it's got a very high specific heat, which means water can absorb a large amount of heat without significant increase in temperature. If you add heat to the body, the temperature doesn't change much. And so that's one thing about water. And the second thing is that if the temperature is above body temperature, you can only lose heat by the cooling effect of water by evaporation. Evaporation cools you down. So two thermal properties of water are essential to get rid of the heat in the body, to counter the rise in heat and to get rid of it.
Still, another part of nature that's fit for the human body is light. Without the special properties of light, the high acuity vision of the human eye would be impossible.
Light has to have the right energy level for detection. And when you look at the electromagnetic spectrum, which goes from gamma rays to radio waves, the visual region is just really a tiny spike. Photons in that particular region of the spectrum have just the right energy for photo detection. Given the dimensions of the pupil, commensurate with our anatomical design, the wavelength of visual light is just right for an eye of our size. That's the highest resolution you can get.
High acuity vision is possible because of the eye's ability to focus light onto the retina, where photoreceptors process the images. But this is only possible with light in the visual range. Given the size of the human eye, infrared light, which has a longer wavelength than visible light, would give much lower acuity vision if it was detectable. And a longer wavelength of light would require a larger eye and different photodetectors in the retina.
If the wavelength had been, say, 10 times bigger, you'd need an eye the size of the head. And if it was 20 times bigger to get the same acuity, you need something like the size of a car. So if you apply those laws of optics to the human eye, you can have a very high acuity eye, the size of the human eye. And it depends on that great coincidence that the electromagnetic radiation with the right energy for detection has the right wavelength for high acuity. So it's another general fitness of nature. High acuity vision is absolutely essential. You know, if we didn't have high acuity vision, we would never have had technology, science, fires, or anything. And it's just as if, in fact, our biology, our physiology, was envisaged at the very moment of creation itself. Long before there was our galaxy, right at the very dawn of time, an intelligence had fiddled, to quote Fred Hoyle, fiddled with the laws of physics and chemistry and the properties of matter, with advanced life like us in view. So what's the bottom line? A special utility in the nature of things for beings of our biological design. It fills me with absolute awe. We're not products of chance or contingency. No, we were specified from the very beginning of time.